All right, you've done it a million times, right? You hit that power button, and a few seconds later, boom, your desktop pops up. But have you ever stopped to think what in the world is actually going on in that mysterious little gap between the click and your cursor appearing? I mean, it really does feel like magic, doesn't it? One second, you've got this silent, dark box, and the next, it just springs to life. But no, it's not magic. It's actually a super precise, very logical sequence of events that every single computer has to follow just to wake up. And that whole process, well, it's got a name. It's called booting. At its core, it's all about loading the operating system. Windows, Mac OS, from your hard drive into the computer's active memory, its RAM. And trust me, without this step, your computer is nothing more than a very expensive paperweight. Okay, so where does it all begin? Well, the very first thing that happens is kind of like a wake up call for all the hardware. The computer needs to make sure all of its physical parts are there and, ready to do their jobs. So, the very second you press that power button, this special little piece of software that's literally built right into the motherboard, it's called the BIOS. It wakes up. And its very first job is to run something called a power on self test, or POST for short. This is basically the computer doing a super quick check of all its essential parts, like the memory and the keyboard, just to make sure everything's plugged in and working right. Oh, and if you've ever heard a weird series of beeps when you start your computer, yep, that's the post telling you, Houston, we have a problem. Honestly, a great way to think about the post is like it's the computer's first moment of being awake. It's like it's just woken up, it's doing a quick stretch, and it's asking itself, okay, are my brain, my eyes, and my hands all connected and ready to go? So once that hardware check gets the all clear, the BIOS needs to know what to do next. It gets its instructions from this tiny little memory chip called the CMOS. Now, this chip holds a bunch of important settings, but the most important one for us right now is the boot order. This is just a simple list that tells the BIOS where to start looking for the operating system. Like, should it check the hard drive first? Or maybe a USB drive you've got plugged in. All right, so the hardware is checked out and the BIOS has its marching orders. Now the computer is ready for the next big phase, the hunt for its brain, the operating system. So, following that boot order we just talked about, the BIOS starts scanning the very first part of whatever storage device is first on the list, which is usually your main hard drive. It's looking for a tiny but absolutely critical piece of code called the Master Boot Record, or MBR. You can think of it like a giant signpost that says, hey, the operating system starts right over here. So, what happens if the BIOS goes through its whole list, the hard drive, the USB port, everything, and it just can't find an MBR anywhere? Well, that's when you get this infamously frustrating error message. We've all seen it. It's basically the computer screaming, hey, I looked everywhere you told me to, and I have no idea how to start. Okay, but let's assume it does find the MBR. That little piece of code has one and only one very simple job. It has to load the next program, which is called the bootstrap loader, into the computer's memory. The analogy here is perfect. The MBR is like the key that unlocks the door, and the bootstrap loader is the person who actually steps inside to flip on the lights. And this, right here, this is the official handover. Think about it. Up to this very moment, the hardware's own built in program, the BIOS, has been running the show. But now it passes the baton over to the software. The operating system itself is finally starting to take control. So the bootstrap loader gets to work, and its job is to pull the most important, the core files of the operating system into RAM. Then those files load something called the command interpreter. That's the part of the OS that actually understands your mouse clicks and what you type on the keyboard. And for the final step, the system runs any startup scripts to get your personal environment all set up, and just like that, the whole process is complete, your desktop appears, that little cursor starts blinking, and the computer is now fully awake. It's just sitting there, waiting for you to tell it what to do. All right, so let's put all those pieces together. As you can see, it's not magic at all, right? It's just a really clear, logical sequence that passes control from the physical hardware over to the software. Now, you've probably heard people talk about a hard boot versus a soft boot. Well, it's pretty simple. A hard boot is when you physically cut the power, pressing and holding the power button or unplugging it. A soft boot is when you use a software command like clicking restart from the menu. It's usually faster because the system can skip some of those really early hardware checks we talked about. And hey, if you want a simple way to remember this whole chain of events, here's a little memory trick for you. Just remember the letters P, B, M, B, O, C, A. That's P for power, B for BIOS and its post check, M for the master boot record, B for the bootstrap loader, O for the OS files, C for the command interpreter, and finally A for AutoExec or your startup scripts. PBMBOCA. Got it? So, the next time you turn on your computer, maybe in that little pause before the screen lights up, you can think about what's really happening. That booting sequence, it's the essential, totally invisible bridge. It's this incredible, carefully choreographed dance that transforms a pile of silent, lifeless hardware into the powerful, interactive tool that we rely on every single day. And there you have it. That's how your computer wakes up. We've just pulled back the curtain on one really complex, invisible process. And it kind of makes you wonder, right? What other invisible systems are powering your life every